Welcome to another great episode right here on IT Pro TV. I'm your host, Ronnie Wong, and today we're taking a look at Project Management Professional, and here to help us, Mr. Don Pizzette. How's it going?
It is going great, Ronnie. Glad to be back on the show and ready to jump back into the world of project management. In this episode, we're going to be taking a look at process analysis. And this is kind of one of those funny topics where in the past, we usually leave this one out of project management because inside of the project management world, we're really concerned with moving our project forward, creating those deliverables, hitting our goals, and wrapping the project up on time, on budget, and meeting everybody's requirements. But there's ongoing activities that happen inside of our company, things that our company does over and over and over again. And there's processes that are a part of those ongoing activities, and they can be improved or corrected, made more efficient, and that's a real thing, something that happens inside of organizations. But we don't normally deal with it in terms of a project because remember our definition of a project. Way back, probably in episode 1 of this series, we said a project is something that has a well-defined start and finish, right? That a project is not something that just rambles on and on and on without definition, that you have a well-defined beginning and end. And you've got a set of requirements that you need to meet, and if you meet those requirements, then your project is successful, and if you don't meet those requirements, you fail, right? So an ongoing activity, that's kind of outside of the realm of project management, so why are we bothering to talk about it here? Well, in every single episode we've covered so far, we've talked about processes, right? And each process had inputs, had tools and techniques that we applied to those inputs to then create outputs, which all hopefully led to the completion of our project, right? At a minimum, they created information we could use to measure our project, but hopefully they created deliverables that then combined like a Lego kit, and all of a sudden you end up with this giant product, right? So that's what we hope to have. Now those processes, those are being done over and over and over again throughout all of your projects. And so there's areas that can be improved there, there's areas that can be tweaked and adjusted, and that may be a part of our project, or it might be our project to find areas to improve. And so this is one of those areas where process analysis is not normally a project management concept, but can be a part of project management. And so we need to have an understanding of that. Now, the PMI, the Project Management Institute, didn't really harp on this much in the past, but starting with their January 2016 update, they're really putting a little bit more of an emphasis on process analysis. So it's a good idea to have at least a foundational understanding of what process analysis is. You as a project manager will likely not have to do this, but you need to be familiar with what it is so you can get the right people to make them do it and actually have this be successful and keep your company running smoothly. All right. So that's what we're going to do in this episode. We're going to take a look at some of those different methodologies or schools of thought on process analysis, what we can do, what we can do to improve things, and how that kind of gets rolled into a project.
Now, Don, I understand that we might actually choose as an individual company to do it our way, but there are some different methodologies that have been tried and true that really do help, well, just about everything that you do, especially project related and those ongoing processes. And there's really 3 main methodologies that we do need to focus in on. So, Don, the first one, I've heard about it. I've heard all different things about it. I still don't know much about it itself. It's one that we call Six Sigma. So it's even hard for me to say.
I get a lot of questions about Six Sigma, and viewers like you out there where they'll send me an email and say, hey Don, I'm thinking about getting into project management. Should I do PMP or should I do like Six Sigma Green Belt or something? And I kind of look at it, I'm like, well, all right, here's a person who hasn't used Google, and to find out that they're really 2 different things, right? Project management is one thing, and process improvement or Six Sigma for that matter is a different thing. They have different purposes, right? What Six Sigma looks to do is it looks to improve processes to make them more efficient and to create less waste, right? Less defects, right? It all boils down to defects. Remember that a lot of this stuff didn't originate in IT departments like what we do. It originated in manufacturing, factory floors, right? Six Sigma actually came out of Motorola. Now, Motorola, if you're familiar with them, they make cell phones, they make all sorts of electronic devices, they do a ton of stuff. And when you make electronic devices, they actually build it into their process that some of the devices they make are going to be broken, right? So if they make 100 cell phones, they may know that just as through a part of manufacturing, 5 of those phones are going to be broken. And then when they build it out, if they need 1,000 phones, they don't just do 10 runs of 100, they do 11 runs. Because they know they're going to lose 5 with each run, so that's 50 total that they lose. They need 1 extra run to be able to get the extra phones to meet their need, right? They do that to meet their goal. Now, they could just stop right there and say, well, that's a cost of doing business. We lose 5 out of 100, that's just it. But if we look at it, right, we start to find the problems, try and find the defect. Why are those 5 failing? We might be able to find some solutions. And we did talk about that in some of our other episodes. We did some of the, the risk analysis, really, because it's a type of risk. But we talked about continual process improvement and ways to do the cause and effect model to say 5 phones failed, why, right? What caused it? And it may be more than one thing, and so you can do like a Pareto diagram. We saw those too, and we talked about how we can isolate which one's the primary cause and see if we can fix it. And when something's a defect, there's different levels of defect, right? It could be that it is completely unfit for use and it just has to go in the trash, and that's that, right? But sometimes they can be repaired. And the repair might even be really simple. If the repair is simple, it might be worth it for us to do it. If the repair is complex, the cost to repair it may be more than just making another one, and that's when we just accept that that device has failed and that's the end, we throw it away, right? So somebody has to make that judgment. Somebody has to evaluate it, and it's normally engineers. It's normally the people that are building this equipment, that are building the process line, not the project manager. But we need to be aware of it because somebody may have told us, yeah, it's just how it is. We lose 5 for every 100 we make. That's just how it is. Well, okay, I'll grant you that. That may be how it is, but that it isn't necessarily how it has to be, right? Maybe we could make it better. And if I can improve that yield, not only am I going to be more efficient, but we could get things done faster. It could help my schedule as well as my budget. So for a project manager, that's valuable, right? So at Motorola, the gentleman who came up with it, the most generic name on the planet, Bill Smith, I guess it could be John Doe, but Bill Smith, he created this back in the 1980s. And what it was just a process used for monitoring production. And it's really designed for a factory floor, right? Industry, where you're actually making a tangible good. But you can do this in IT or project management where it's a soft skill, right? This could be things like looking at your help desk calls. And you could measure defects based on customer satisfaction scores. At the end of a help desk call, you ask whoever called in to do a survey and rank the experience on a scale of 1 to 10. And you could say, look, we're trying to create an 8 to 10 experience. And if somebody says they had a 7 or lower, that's a defect, right? And do we have an acceptable level for that we're okay with? Or do we need to try and get that up higher, right? So it doesn't have to be a tangible item. And that's where Six Sigma gets really weird, because it was designed for industry, and now people are applying it in all sorts of different places, and it becomes really, really powerful, all right? Now, the name Six Sigma, what it actually derives from is Sigma is a statistics term, and it means a standard deviation. So when they say Six Sigma, Motorola had this target back in the day that they wanted to make sure that they stayed within 6 standard deviations of what was considered perfect. So you could get a little bit off of perfect and still have an item that was sellable, that still fit its need, right? Fulfilled its purpose. And remember your warranties, right? You got to be fit for use and fit for purpose and all that good stuff. So so that's basically what we see with Six Sigma, and that's where that name came from. Now, they don't actually shoot for Six Sigma, and they shoot for something like 4.5 Sigmas or something, but that was the name. I'm not quite sure why they switched that one up. I guess that maybe they just got more efficient over time. But basically, it's a pretty lofty goal, right? Their goal originally was something, I got to try and remember this, it was something like 3.4 defects for every 1 million possibilities of defect, right? Now, when you produce one cell phone, there are thousands of possible opportunities for defect in that phone. So to produce a valid phone, that could be 1,000 successes in that one phone. It could be 10,000 successes. So when they say 3.4 defects per million opportunities, it doesn't mean they made 1 million devices, but it means that it could be a much smaller number. But that was kind of what they were shooting for back then. When you apply it, it doesn't necessarily matter, right? When you apply it, what really matters is the process. And this all goes back to Deming. I know we've mentioned Deming in other shows, but he's got that whole plan, do, check, act methodology, right? Plan. We plan what we're going to do, right? We figure out how we're going to run through it. We plan our project. We do. We execute. We actually perform whatever that action is. Check. we evaluate the results. Did it work the way that we planned it? Or did it not match up with the plan? If it matched what we planned perfectly, right, to perfection, then we're done and we move on. But if it didn't match, if it was too good or too bad, remember, like any risk, there's good risk and bad risk, so it could be too good. Why was it too good? Let's find out. And then we act. We make any changes necessary to get things back in line with our plan. Plan, do, check, act, right? Very old methodology there, right? That's Deming's kind of key analysis. So what Bill Smith did is he took that and he just modified it a little bit, and it's implemented in 5 steps. And there's a little acronym that you'll see used anytime you read a Six Sigma book, which is DMAIC. This guy right here, DMAIC. You'll hear people call it DMAIC or DUMAIC. I've heard both. I think DUMAIC is kind of the most common one, which to me almost sounds like demonic, so I don't normally use that one. But DMAIC, define, measure, analyze, improve, control. All right, define. That's like our plan, right? We figure out what it is that we're going to be measuring to evaluate the system, what it is we expect to get, right? Measure. We collect data. If we're going to be evaluating this, we have to have some kind of measurable thing. Remember the help desk example I gave you? I can't just arbitrarily decide if a help desk call was good or bad, but if I base it on customer satisfaction, now I've got something that I can measure, right? Let's say that you're a fast food restaurant and you make hamburgers. How do you measure whether that hamburger tastes good, right? Can you measure taste like that? I don't have a taste meter I can stick in there and say, no, this one's a 7.5 on the taste scale. It doesn't work, right? But if you measure your customer satisfaction or something else, a temperature, appearance, something like that, those are measurable items, right? So we measure. And then we analyze. We analyze the data we got to see, does it match what we defined in the beginning, right? This is basically plan, do, check, act, right? The act part, though, becomes improve. Can we make it better, all right? I'm getting 9 out of 10 support calls that are getting an 8 or higher on their evals. That's great. But what about that 10th one? Could I get that better? Or what if all 10 were an 8 or higher? Could I get all 10 to be a 9 or higher? Right? Let's improve. Let's see if we can make it better. Now, there does come a tipping point where improving would cost more than it's worth, right? You wouldn't get the necessarily benefit. So you go through this cycle a few times before you kind of reach that cost to benefit equalizer. And then lastly, we've got control. Control says, all right, we're going to keep doing this. How do I make sure that I always get consistent results? And the best example I can get for control is maintenance, right? I know if I get in my car in the morning, I can turn the key and it starts up and I can drive to work. I've done it 1,000 times. Well, probably more than that, right? So I've done it thousands of times. Get in the car, drive to work. I know the car can do it. But I still have to change the oil in the car. I've got to put gas in it, right? That's me controlling. I'm controlling to make sure that car will be able to get me to work tomorrow, right? I already know that I've measured it. One tank of gas will get me to the office. I know my car can do that. I've analyzed that. But if I don't control it, if I let it run out of gas, if I don't change the oil, then everything kind of goes off and it just doesn't work anymore. So we've got to control, right? And that's really the core principle of Six Sigma, is this process right here. And it's a constant cycle. You're going over and over and over again, cycling through that to make it better and better and better and minimize those defects.
Now, Don, with this process, we know that its main function then is really, when we talk about Six Sigma, is to try and eliminate those deficiencies that are in our products, as well as actually to become more efficient and making better products as well. But sometimes we have to do the opposite, which is that the process that we're doing has to do with a lot of wasted motion, right? And in this, we might turn to another type of methodology that we call lean, I think is what the term is.
Yeah, and boy, lean is thrown around a lot. So lean is another one that comes from the past, right? So this one just comes from like way back in the past. I mentioned how Six Sigma came out of Motorola in the 1980s. Lean actually came out of Toyota back in the 1950s, right? So we're talking about a 60-year-old methodology here, creeping up on 70 years old. The gentleman who kind of created Lean, his name, and I'm going to have to read this off the paper, is Taiichi Ohno. All right, Taiichi Ohno, who actually, he's responsible for a number of different things in the project management and the process improvement world. So you'll see his name in various books. But what he did is he said, no matter how good a process is, when you look at it, there's waste. There's always waste of some sort. And so we need a way to improve upon that by minimizing the waste. If we can minimize the waste, our process might still take the same amount of time to complete. We might still have the same amount of defects, but maybe we can reduce our company's expenses or whatever to make us better in other areas. So he took a little bit more of a holistic approach to process improvement. And what he came up with was this list of what he called muda, which is the Japanese word for waste or garbage or something. I don't know, but basically we have this 7 places where people will typically generate waste. All right, and there's a simple acronym for this. I've got it here kind of on my screen, which is called Tim Wood. Right? If you read a lean book out there, you'll see this acronym mentioned somewhere because it's easy to remember. But basically, it boils down to the 7 areas where people are wasteful, where a process can be wasteful. Right? The first one is transport. If you think about transport, anytime you have to move something from one location to another, the whole time it's being moved, it's like being held in reserve. You can't make money on something that's in the process of being moved. You can't use something while it's in the process of being moved. So if we can minimize the amount of time that it's being moved, that can help to minimize waste. All right? And putting this in terms of Toyota, when they manufacture a car, if they then have to stick it on a barge, one of those giant freight liners, and ship it from Japan to the United States, that could take 2 months. And during those 2 months, they're holding on to that inventory. That's money that they're not gaining interest on, that they're basically losing money on. And then as soon as it gets here to the States, they can sell it and they make the money back. But the shorter they make that trip, the faster they can get their money back, and the faster that money can go into their next project and continue to improve the company, right? So transport is kind of a big one, right? In IT, we don't see transport as much, but in other industries, it's a very real thing. Inventory is another one, right? Inventory, if you have to hold things on your shelf, look at a grocery store, right? If you were to take a grocery store and close the doors and tally up the dollar value of all of the items inside of that grocery store, it's a lot of money. Money that they're sitting on that they don't recoup until they sell that item. And when they sell the item, what do? They buy a replacement to put on the shelf, so they've always got that inventory in place. Anything we can do to reduce the inventory that we need but still keep the customer happy, right? That's the real trick right there, because you don't want to make your item hard to get, because then people will just go and buy a different item, right? So, but keeping it to the minimal level necessary is going to help our company to be able to respond to changes faster. Motion. This is kind of a weird one, because we talked about transport. What is motion? Well, it's really not just motion by itself. It's really talking about too much or too little motion, right? So, for example, let's say you get a new appliance like a dishwasher, and you're installing the dishwasher and you push it into place and you push it a little too far in, or you don't push it far enough in. What do you have to do then? You have to do what's called rework. You have to go and push it to be right back in the correct spot. So anytime you have a moving part, there's this possibility that things may go wrong, right? The moving part could wear out. The moving part could go too far or too short, and now you've got to adjust with that. So anytime you have motion, you can have unnecessary motion, and that's an area where we can have waste. Waiting, just waiting in general. And this is one in IT I can absolutely relate to. I know, Ronnie, I've told you before, like, half my career has been spent watching a blue bar scroll across the screen to get to 100%. That's the world of IT. Could I have been doing something else, right? Can we multitask? Can we do other things to achieve? So when we wait on something, and using Toyota, they paint a car. You gotta wait for the paint to dry. Is there something we can do to minimize that waiting time? Could we have heat lamps that bake the paint so it cools or dries faster or whatever? I imagine so. Right? I've never made a car, so I don't really know, but I imagine so. And those are ways that we can improve our process. Overproduction. All right. Overproduction. Ronnie, you are the master of overproduction. Sometimes we can put too much effort into something to achieve it, right? So I might need. I might go to Ronnie. I'm going to throw you under the bus here, Ronnie. I go to Ronnie and I say, Ronnie, I need a web server fired up. Can you spin me up just a Windows virtual machine with a web server on it? And then he'll come to me the next day and say, all right, your web server's up. Oh, and I set up antivirus on it, and I configured the firewall to allow these rules, and I applied all the updates and all this extra stuff that he did, which is great, right? I mean, it really creates that perfect environment. But he put a lot more work into it, and I might not need that. I might have just wanted to test something, and I'm going to delete the server. So that's overproduction, right? More than we need. Anytime you go beyond your customer's requirements, that's overproduction, right? Overproduction can also be where we've created too much of an item, right? So they needed 100, we made 200 just for the heck of it. we might end up having to eat that extra 100 that we made, and that can be a part of it too. Overprocessing, right? Overprocessing is kind of similar to overproduction. You see overprocessing usually when you're manufacturing something like paper or whatever. So paper, for example, is actually brown, and they bleach it to be white, and you can over bleach it, like it's already white enough, and you continue processing it more, you've done more work than was necessary. And then lastly, just defects. And defects are what we normally look for, right? This is where we expected one thing, we got something else, and it's not suitable. That's a defect, right? So these 7 are kind of the core areas. Now there's other ones that are out there, right? But these are the core 7 that they call out in Lean. Now the interesting thing about Lean is that you rarely see it employed by itself, okay? It's a methodology for identifying areas of waste so that we can then work to improve them. So the improvement part, that kind of comes with something else like Six Sigma or other methodologies, or you might create a project to try and improve it and move that forward. So you'll hear about people talking, you'll hear people talk about Lean Six Sigma, right? Or Lean Agile, right? You'll hear Lean Scrum sometimes or whatever. And it's where they're taking one methodology and combining it with Lean. So hey, we're doing this activity, but we're also watching for waste to see if we can improve along the way. So Lean is not so much a standalone item.
Now, Don, I also understand from Toyota, that guy, what is it, Taiichi Ono, that not only did he produce Lean, though, another part that's very important, of course, to Toyota was the idea of inventory processing and control. And so that one's actually called Kanban?
Kanban, yep. Kanban, another Japanese word, I believe it means sign
billboard, yeah, sign.
Billboard, something like that. Yeah. So basically, it literally translates as sign, but a better translation for it would be card, because Kanban works on this principle of cards. It stems from Toyota, right? So basically, as part of eliminating waste and making these more efficient, what Taiichi Ono found was that a lot of times they had a bunch of inventory, right? Just a bunch of, let's just say mufflers, right? Car mufflers or car wheels for that matter. So maybe they had 10,000 wheels and they're about to make 200 cars. Well, how many wheels do I need for 200 cars? 800 wheels, right? So if I have 10,000 wheels, I got way too many wheels for what I need. So all those other wheels are just sitting there, right? They're inventory. And the problem with having inventory is kind of twofold, right? The main problem is that it's money sitting there and you're not using it, right? But the second thing is it stops your company's agility. And what I mean by that is, let's say that, all right, it's 2015, the 2016 model cars are about to come out, and I decide, you know what? Instead of 16-inch wheels, let's go to 17-inch wheels. Well, we've kind of got 8,000 wheels sitting here in inventory. Let's just stay with the 16 inches so we can burn through all this inventory, right? That's what companies do. You got to do that, otherwise you have to eat the inventory. So the more inventory you have, the smaller your ability to change is, right? You can't switch out because you've got all this extra stuff. And inventory actually applies to two things. One, inventory just sitting there on the ground, right? But also inventory applied to work in progress. At any time, you can go to a Toyota factory and they're making cars. There's a number of cars that'll be on their conveyor belt. It could be 100, could be 1,000, and those cars are already in production. If I want to make a change, if I say, ooh, you know what, let's go to this better tire this time because we can get it for less money and it's just as good. Well, I've kind of already got 1,000 cars in process. I can't change those, so I got to wait for those to finish, right? So inventory or work in progress, you'll hear those terms kind of interchangeably if you start studying Kanban, and you'll even see that with Six Sigma and Lean also is kind of pervasive through them. Kanban, though, really focuses on that inventory side. And it basically says, instead of sitting on a ton of inventory, we're going to use cards. And these cards will indicate when we need to buy more tires or when we need to buy more steering wheels, and we'll apply them as we need them. So, for example, I might have a bin and card. Those are the two really important terms you'll hear in Kanban. We'll have a bin that has a bunch of steering wheels in it. And this is how it was back in the 1950s, that when they go to grab a steering wheel, you look at it, you see how many steering wheels are still in the bin. And if I get down to 5 or 10 steering wheels, I take a red card, and it may just have one word, it may just say order, and that's it. It could have very detailed information on there, right? It's up to you how you want to deploy the cards. But let's just say it's a red card that says order, and you drop it in the bin. And then someone else who's the ordering agent comes along and sees that red card and says, oop, I need to order steering wheels, and they order 10. And then as we continue to fill that up and to take it out again. When we get down to 5, we drop that card back in, time to order more, right? So the cards are an indicator of what needs to be ordered so we can minimize our inventory, which saves us money, and it allows us to change more easily. We can say, look, we need to switch steering wheels to this new one that's got volume controls built into it. All right, well, we've only got 10 in inventory, so just the next time we order, we're gonna switch it up. So on the card, we put order, new part number, and you drop that in the bin, and now they order the new part number and you move forward. Now, this is from the 1950s, and I know what some of you guys are thinking. Well, I don't have bins, first off, and secondly, this sounds pretty labor intensive. We got manual cards and people got to write stuff. You see this electronically too. A great example, I don't know if any of you guys have ever used the service called Trello. Trello is like a to-do list kind of software for tracking your own stuff, but it's also great for projects, and it follows Kanban's methodology. When you come in and you whip up a project, you create what are called lists, and the lists are effectively bins. I could have a bin that was called, maybe like work breakdown structure or tasks or whatever. So I might call it upcoming tasks. All right. So there's that list. And then I might have a list called work in progress. These are things that are going on right now. And then I might have completed tasks. All right. So I've got 3 bins. And then in each bin, see how it says add a card? Like the terminology is right out of Kanban. I mean, that's basically what they're doing. So I can come in here and I can start to list the tasks that I've got. So if I'm building a car, right, we might have order tires. We might have, whatever, each of these different items that are going to be in here. And so, paint the frame. So we're going to paint the frame. We're going to do each of these things. And as you start to do that work, okay, I've got this upcoming task, paint a frame. I'm ready to start painting. I'm just going to drag that and drop it into work in progress. And so now I've moved the card, and if somebody comes along and looks in the work in progress bin, they can see, oh, we're painting the frame right now, right? And we haven't ordered the tires yet. We probably should have done that, right? Or they see where maybe ordered tires is already in completed tasks. And so they can look and see the card and they know what hasn't been done, what's currently being done, and what's already done at a quick glance, right? These are cards in bins, and it's the same idea. I mean, this is Kanban implemented electronically in a modern format. There's tons of people out there that use Trello and have never even heard of Kanban, and they're basically using the principle every single day. So this is something that's pervasive. We do see it a lot.
Now, in the area of process analysis, then, there's probably a lot more of the different methodologies that are out there, but these are by far probably the most popular and probably even some of the most effective ones that maybe the newer systems are based off of, right?
Yeah, and what you want to do is you want to take this and kind of fit it for your own company, and you're going to apply it differently, right? Different people have different needs to make it work out. And so fortunately, you don't have to reinvent the wheel. There's plenty of organizations out there that can kind of give you a framework for this. The PMI doesn't, right? We saw it in some of the other episodes where we saw process improvement, some of the different tools and techniques we had available, but PMI doesn't really get into process improvement because that's really an ongoing activity, not a project, all right? But there are some standards organizations and other people out there that can help us with it. I want to talk about each one just kind of in brief, but I know I've kind of already run out a little long on this one, Ronnie. So why don't we do this? Why don't we stop this one and we'll do a part 2. And I want to talk about some of the organizations that are out there that can actually kind of give you that starting point to be able to implement these without having to reinvent the wheel.
All right, so in this episode, remember that we took a look at 3 of the different methodologies that you'll probably end up finding out about, which is going to be Six Sigma, Lean, as well as Kanban. And this is part of those ongoing processes that help us to improve our efficiency, as well as to try and eliminate as much waste as possible, and also to improve that process in inventory and control as well. And that is actually what we need to make sure that we focus on preparing for the PMP exam as well. So signing off for IT Pro TV, I'm Ronnie Wong.
And I'm Don Pizzette.
And we'll see you next time.